In this video, we're going to talk about energy transfer, and by the end of the video, you should be able to determine the direction of heat flow and identify substances with higher average kinetic energy. So first, we need to define a couple of rules or names for the things we're going to study. So the system includes the particles we want to study, and there are three types of systems. An open system where it exchanges energy and mass, so like an open test tube or beaker where the liquid inside could evaporate, they're changing its mass, or heat can go in and out. A closed system where it exchanges energy but not mass. So a closed system would be like the same beaker, or in this case test tube with a top on. So now the water can evaporate, has nowhere to go, but the glass still conducts heat in and out, so it would change temperatures. The best case for this unit we're about to talk about with heat is an isolated system, one where it doesn't change energy or mass. So not only is there a top so it can't evaporate, but there's a covering on the outside like a thermos that you might have for keeping your drinks cold or hot in order to keep the heat in or out of the container. So for the labs that we're about to do and to discuss, they should be isolated systems so that the system can't really change its energy or its heat mass. The surroundings are going to be defined as anything else that you're not really looking at, not those particles. So the surroundings could be the container itself, the top, the air, right, around it. So that's where, if you're talking about heat, it could go there or come from the surroundings. If you're looking at the particles, that's the system. There's two types of energies we're going to be focusing on. Kinetic energy is the energy of motion. Some people refer to it as thermal energy. So the more kinetic energy the particles have, the more they move. And potential energy, which is the stored energy, is inside the particle, reserved for changing. And we can usually say that's called phase energy as well. And so what is heat? Heat is the movement of the energy from an object of hot energy and high kinetic energy to cold or low energy. Like we said in the previous unit, from where it is to where it's not. So you always go from hot to cold, and you can see in this picture of the particles, the heat's going into this particle and spreading out from where it was hot to where it's not. Another example of how to think of this is if you're talking about like hot chocolate, the heat would be going from the hot chocolate to the surroundings. The hot chocolate is our system, and the air is the surroundings. If the hot chocolate's hotter than the surroundings, 22 versus 80. Whereas ice cream, where it might be colder than the surroundings, the heat's going inside ice cream to melt it from the surroundings to the ice cream particles. Another example that you might be asked is in terms of heat flow, what happens when an ice pack is placed on your skin? And some people say, oh, the cold goes into my body, but that's not really accurate. Cold can't move. It's the heat the particles have. The particles move with that heat, and so in this case, it should really be that the heat is leaving your body and going into the ice pack. As far as temperature is concerned, it only measures the kinetic energy of the particles, or how fast they're moving. So the higher the temperature is, the more they move. If it's a low temperature, they don't move as much. So you can see as they move farther away, that bar of temperature is going up. So lower energy would be diagrammed with smaller arrows, and higher energy is diagrammed with larger arrows. So it's saying the lower temperatures can only move a small amount in a second, whereas the higher temperatures can move a larger amount in that same second. Here's another example you might see on the Regents exam. In which sample of water do the particles have the highest kinetic energy? So kinetic energy, again, is the energy of the temperatures, and so it doesn't really matter how your volume is, it matters more about what your temperature is. So on a question, you can actually read kinetic energy as temperature, and the question becomes a lot easier. As far as the particle models that we're writing in class, usually the way we think about it is if it's hot and it has long arrows, then the heat has to leave that thing and the heat would be coming out of that hot substance into maybe the room temperature. Whereas if there's cold coffee, there may be no heat transfer if the cold coffee is the same temperature as the room. So the particles are not moving as much and there's no heat change. As you can see, there's no additional arrows. At this point, you should be able to determine the heat flow from hot to cold and identify substances with the highest average kinetic energy.